All right, everyone, we are on our last problem set. I know everyone is so sad. But we are on our last problem set together for problem set 8, and we're going to be doing our ANOVA analysis. So for each of these data sets, we're going to be doing kind of the same analysis, which is which are statistically significant, what are large effects, small effects, and if we wanted to maximize our outcomes, how would we analyze this? So let's go ahead and let's start doing our data sets. And I'm going to do them kind of basically all kind of out of order or just as they appear. So let's go ahead and we can actually take our pages on our Canvas site and we can go to week 11 and we can go to our ANOVA and then we can read this in and let's start to work. So I'm going to go to my downloads. I'm going to set this as my working directory. I am going to read in all of these values and let's start to take a look at what data sets that we have available to us. So we have all these dentist, sour cream, all these good things. So let's start to read those in. So I'm going to go ahead and let's start with, actually, let's go in order. So where's my problem set? So we're going to start with dentist first, and let's get started. So I'm going to open up. Let's go to, we're going to do read it in, those libraries. Let's do library read Excel because we're going to be working with Excel files, and we're going to read underscore XLSX, and we are going to read in dentist updated. Should be happy because not csv.xlsx, and I updated it, put it in a nice format, even though you should have been able to do it, but I'm just such a kind professor. So let's look at, we have dentist method temperatures. We're seeing how hardness varies as a function of these parameters. So we can go ahead and type in dentist method and temp, and then finally hardness. Temp, hardness. So this is going to be our factor 4, and that's going to be hardness. Factor 1 will be dentist. Factor 2 will be method, and factor 3 will be temp. And then we need to reset this to the third column. So we're just reframing our data set, setting which are factors, which are not. Ooh, you didn't like that? Let's see. Now we can see a summary. So it makes sense. We're treating these now as factors and these as numerics. So we can start to set, we're going to examine hardness as a function of dentist plus method plus temp plus, and I'm going to go dentist method 2A interaction plus method temp plus temp dentist, and then I'm going to do plus our 3-way interaction of dentist method temp. So this will be, I'm going to keep this template for any time we have a 3-way interaction. So we've got this, we have our results. So as we see here, none of these interactions are statistically significant. We can see here, basically no interaction or very weak, nothing. Interestingly, both the dentist temp and dentist method temp have a large effect on our analysis, but because these are all statistically insignificant, and actually we can dive deeper into that. Let's look at hardness, and let's look at the factor, let's look at dentist. So if we do this, we see none of these are statistically significant. I wonder if we can do dentist. I'm just playing around here. Dentist method, temp. It's not going to allow me to do this. Yeah, exactly. So we see that there are no statistical differences for dentist. We can do the same thing for method. We can do the same thing for temp. And we're going to see So we can't make any suggestions, but interestingly, again, we saw that there is kind of almost a large effect for, or close to, I mean, actually, definitely a large effect for dentist temp and then dentist method and temp. So nothing matters in this problem, so let's move to the next one. So let's go ahead, not Mathematica, auto insurance. Let's read in this data set. So I'm going to keep this general, and then let's move it down. So let's do auto insurance. Auto insurance. Insurance. Spelling is not easy. So let's do auto insurance, size, region, premiums. So size, region, and premiums. Premiums. So we can get rid of this. So this is our two-way interaction. So size, region, and then premiums, and then not as factor, but as numeric, because that's what we want to analyze. And then I'm going to delete our old friend hardness. Go away. Oops. Good. Summary. Again, we can see, okay, we're good to go there. So now we just need to change our factor is going to be premiums, and we are going to examine, I just like to retype these out just to practice. Size plus region plus size region. So there we go. We can now head over, actually, let's rephrase this. Let's look at our summary. Hold on a second here. Ooh. What's happening here? What does this look like? Region. Something's happening. Size, region, premiums. So let's actually read. There we go. That's much better. So, as we can see here, size, region, none of these are statistically significant if we're working at a 95% confidence interval. If we look at the size of the effects, small, 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 and then we could also look at premiums, and then we can also set up, let's look at size. None are statistically significant as we see, and then also if we look at region, same result. That's just the name of the game. All right, none of these matter. So, on to the next one. Where's our... We can't say anything about the data set. Let's look at interest. So, interest rates. Good. We don't want to select that, but let's look at our... So we have city and interest rates. So we have city, and then we have interest. That is all. So we have city, we have interest, and I'm going to do it as a numeric. And we can delete this. Oh, you don't like this. What don't you like? What don't you like? Boom, boom, boom. All right, so let's look at a summary. There. Now it can stop harassing me. City. So let's go to. We are going to look at interest, and then it's only a one-way ANOVA, so it's just going to be on city. Indeed, it is statistically significant. That's great. Large effect size, even better. So let's look at interest. And let's look at city. So we can actually, and then actually let's visualize this. So I'm going to do x-axis. I'm going to have city, and then I'm going to have interest. So it's an important parameter. If I wanted to increase my interest rates, which I don't know if I'd want to do that. 5 and 6 are certainly statistically significant. Let's look at all of our factors. So really, the only ones we know are different are 1 and 6, 3 and 6, and 5 and 6. So if we want to minimize interest rates, which we probably would want to do, you could choose 6, but if we look at the variables here, 6 and 1 are different, but 6 and 2, 6 and 6 and 4 also, we can't tell the difference between them. So if you want to maximize it, on the other hand, you may want to choose 5, but we see, and if we can compare, if we look at 5 and 6, they are different. But 5 and 3, they overlap. So there's no difference here, and then also 5 and 1 as well. So you can equivalently say that this, and this there's no difference. Actually, even 5 and 2, we see that they are not statistically significant, at least at our confidence level. So we want to be careful. It's a big effect. We'd want to investigate more. I'd probably run more experiments. So if we want to decrease it, I would probably select 6. But 6 and 2, basically, again, we saw before, 6 and 2 are basically not statistically, significant. So 6 or 2 would be effectively equal here. So just be cautious as you run those ANOVA tests and run those values. Excellent. So let's see, data set. Concrete. So let's look at concrete. I think that's a good old 3-way ANOVA. So let's hopefully, did we keep, oh no, did we just destroy our data set? No, I think so. Let's look at this. So let's go to concrete. Concrete. Good. Except let's look at concrete now. Oh, no. Concrete's a 1-way too, so let's stay here. Concrete. So concrete has ag and moisture. So we're just going to flip it. So aggregate, moisture, ag, moisture, and then let's look at moisture, ag. We do see statistical significance. Excellent. So let's look at the values. Large value as well. I have a penchant for curiosity here. City, 0.33. Force is not interesting. We have very similar data set on there. But anyways, moisture and ag, you can see those values, significant. And then let's look at ag. Actually, excuse me. Moisture, we have ag. Actually, those two data sets don't look the same. I'll have to look at that a little bit. I'm just slightly interested here. Rates. Concrete. Nope. I'm going to leave that. Leave that as such. So let's go ahead. Sorry, I was just... Actually, we have some very similar. Let's plot. Let's do ag. Let's do moisture. We see very similar. I think we have a little bit of an issue here with our concrete and interest rates. Because if we look at this, our moisture should be 55. So let's rerun this data set. I want to look at this. There we go. Okay, sorry. Still large effect, but now we're seeing some differences. My mistake there, or not my mistake, but we just need to rerun. All right, so if I wanted to increase my moisture rates here, so we see that it is statistically significant. It is a very large effect. So if I want to increase my moisture, I may want to pick a value like 5, but you see that there's not statistically significant differences except between 4 and 5 and 2 and 4. So again, we can't say significantly. Now, if I wanted to say 4, if I wanted to decrease it, I would probably pick 4, but you can see that 1 and 4 are not statistically significant. So those would be equivalent. If you look at 2 and 4, there is a difference. But interestingly, if we look at 3 and 4, there also is difference there. If we look at 5 and 4, we also have significance there. So if we wanted to minimize it, we can do 1 and basically 4, but 1 and 4 would be equivalent as well. So you would say if I want to minimize, I want to do 1 or 4. If I want to maximize, unfortunately, there's a lot. So I would do 5, 3, 2, and basically almost and 1 as well, because 1 and 5 are not statistically significant. So basically anything other than 4 if I want to maximize. So excellent. Last one. Let's go. We did the concrete. Now we need to do our sour cream data set. So let's go ahead and look at our sour cream. What is that data set? Are we looking at a one-way, two-way, three-way? I think we're looking at a three-way ANOVA. So let's go ahead and let's do sour cream. And then let's look at it. Yep, that's a three-way. So let's go ahead and we are going to look at several different parameters here. So we're going to look at batch. We're going to look at position. We are going to look at brands. And we're going to look at acidity. So basically how these three factors affect acidity. So again, batch, position, brands, and then acidity. And we're going to get these. We should probably, again, let's go. All right. And then now let's do acidity. And then let's do batch. We're going to replace all the dentists with batch. We're going to change all the methods to position. And then finally, we're going to change brands, all the temps. No more temperature. Here we go. Acidity. Spelling is important. But it looks like we don't have any information on this data set, and we don't have enough values that even give us batch position, or basically we have batch position. Even the brands aren't giving us. We don't have any information on brands. Plus brands, plus batch. So it's not even spitting out those values. So we can look at our data squared. None of these are basically, we have a middle for the group here, but if we look at, for example, acidity, and then let's see if it even gives us anything for batch. Batch, true. What about brands? Not significant. And then also for our position. Yep, so none of it matters. So there you go. End of problem set 8. Study well for your final, and we'll see you in the next video. Thanks. Bye.